One tiny mistake in a C++ loop, and your program will run forever.
Bruh.
That's just one line of code and endless emotional damage. Now you want to print out numbers 1 through 7, but you don't want to just print them out normally. You want there to be an enter line between each of the numbers. How would we do this? Well, there's actually two ways we can do this. The first one would just be to print it out normally. This twin is also not programming. This is clerical work. And the fastest way to introduce bugs. Also, if I ran this 1,000 times, heck, 10,000 times, I'd probably lose my ration allocation. For a week. Now imagine if I could automate this and make it go from 1 to 7 in a format exactly the same as we had it before. Thankfully, something like that already exists, and that's a for loop. So whenever we start a for loop, we have to first start with its bounds. In this case, we said we wanted to start at 1, which, don't do this in actual programming. This is a cardinal sin, starting at 1. But just for our example, because we want to make it exactly how it was before, we're going to say I equals 1. Now, we have to define where it's going to stop. Any idea of how we might do this? So I has to be what in order to stop? If we're starting at 1, right? We have to go 1, 2, 3, 4, 5, 6, 7. That means that it has to go from 1 to 7, meaning we stop right before what? That's right, 8. Then it's I++, and all I++ means is I equals I plus 1. It iterates, and it basically takes it to the next one. So it's 1, 2, 3, 4, 5. You get what I'm saying. Then we include the brackets. You don't actually need to include them, but I include them just because it looks nice. And finally, now that we have everything set, we just put the format that we want. So we wanted I, which is going to be whatever I is in at that moment. And then we're going to say the same end line, boom, space, and boom. Ta-da! It worked! And this, my friends, is what we call a for loop. So far, we've covered two types of loops. The first example was while loop, and the example we just used is a for loop. However, these for loops rely on something called conditions in order to actually work. Our while loop required one thing to be true in order for it to continue to run, and our for loop required that we stop right before 8. Which brings us nicely into something called conditionals, which I'll show with this example. Here's an example of a conditional. My partner will crash out if I get any more than 5 cats. Any less than 5 cats, and I might be able to convince them to get another cat. Currently, I have 4 cats. So what do you think will happen? Will my partner crash out? Or will they be reasonable about the number of cats I have? Well, let's just look at this. Is 4 greater than 5? No. So my partner is probably not going to crash out about the number of cats I have. And we'll get this print statement here. We might get another cat. However, if instead we say we had 6 cats, then this condition would activate, and I would get this, actually a nicer condition than she might say, but in any case, that's too many cats. I went ahead and typed out a conditional and a loop, specifically a while loop, so you guys can see the difference right here. A conditional will either give me one or the other, depending on the condition. However, a while loop, if I put, let's say, 6 or anything greater than 5, it will continuously go down because cats minus minus, which is just cats equals cats minus 1, right? So it's going to continue to go down by 1. So if we're starting at 6, it's going to go down to 5, it's going to go down to 4, and then at 5, I will stop getting yelled at. The difference between a conditional and loops is very subtle. Conditions make a decision once. If this, then this. If not this, then this. A loop, however, repeats until a condition changes. But why am I yapping about this at the same time? Loops and conditionals. Because loops depend on conditions. A loop keeps running while a condition is true. Which is why I'm going to have us work with a while loop again. Because these can be quite finicky. Remembering the previous example, is there anything with this that looks wrong? just looking at it. So we're starting at int I equals 0. So I is at 0. That's where it's starting. And while I is less than 10, it's going to print out I and then end line or enter the next one. So looking at our bounds, why is this happening? Well, I equals 0, right? And I is less than 10. Is I ever going to be less than 10? Well, think back to our last example with cats minus minus, right? Cats minus minus is just equal to cats minus 1, meaning that it would go down every single time until I wouldn't get yelled at. However, here, in this case, going down wouldn't be the answer. In fact, it would want to go up to meet this condition to stop printing I. So it would be cats plus plus, which remember we said in the beginning is just cats plus 1. Or I plus plus equals I plus 1, right? Let's be fun about it, right? Because I feel like putting I plus 1 is very, very boring. Let's say instead we wanted to go up by increments of 2. What would we have to do? We do this. All we're saying is that when I equals I plus 2, meaning that every time this goes through the loop, it's going to add 2 to the previous value. So so let's count it out. Let's go ahead and count out exactly what's happening. So it's going to start at 0. It's going to reach the end. 0 plus 2 equals a new I, which is 2. Then 4. Then 6. Then 8. Huzzah! We got it. But one question comes to mind. Why didn't we get 10? Well, if you look at our condition for our while loop, it stops when it continues to print out only when I is less than 10. Meaning that it's going to get 0, 2, 4, 6, 8, and then it stops. Loops aren't perfect, however. They do have shortcomings. For example, let's just take a random loop I thought of. But I know what you might be thinking. Interno, this loop looks completely normal. I mean, we start at int I equals 0, and we keep going until as long as I is less than 5. And we increment I plus plus, which is just I equals I plus 1. Which means that it would just look something like 0, 1, 2, 3, 4, and then it would stop because we'd reach 5 and then it would stop. And to that, you'd be correct. That is exactly right. That actually lies in the problem. You see, one of the limitations of loops is that once you run it, you kind of have to have a destination in mind of where you want it to end. So for example, let's say we were dealing with an array. With this as our array. And in order to measure our array, we pretty much have everything we need, which is just the size and then I. And it will continue increment up until it reaches the end of the size. Again, that's kind of the problem. We know these values. If you know a value, it's very easy to have a loop go all the way to it or continue to work until it reaches that point. But what if we have something that we don't know the size of it, or we don't know, maybe it shrinks, or maybe it gets bigger than we thought it did? How do we overcome these weaknesses of arrays? Well, welcome to one of the oldest frustrations in C++, runtime memory.